Hello, everyone, and welcome to another exciting session at Miramore Institute. Learn, Create, Lead. I am Williams, senior instructor here, and today we are going to embark on a journey through some of the most powerful features in Power BI using DAX. So whether you are completely new to data analysis or looking to refine your skills, by the end of this session, you will be able to join data. By the end of this session, you'll be able to perform advanced calculations. By the end of this session, you'll be able to create new insights from scratch. So let us delve in. Now we have our curriculum here, and we'll be starting by looking into the very first functions called related and lookup value. We'll then look into the calculate function, the all function, and the filter function. Then we will explore what is known as iterators, sum x, average x for calculations. Now, our mission is going to be more effective with the use of a case study from our Miramore Institute Project Eagle. Now, Project Eagle is a project we are currently on in Miramore Institute, which is on leveraging data analysis in policy advocacy. So our mission today is going to be to leverage data analysis for policy advocacy. And we will be looking at e-commerce logistics. Specifically, when you scroll down, you will find out that this is specifically for Miracommerce. 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 Hope you can see my screen. Miracommerce. So by the end of this lecture, you will not only understand the concepts. By the concept, I mean the concept of joining data with related and lookup value. The concept of iterators, the concept of calculate, all, and filter functions. But you will also apply them to real world scenarios, like the scenario in Project Eagle. So let's dive in. Now, everyone knows here in Miramore Institute, in all our training programs and classes, we first of all start by setting the stage. By setting the stage, start by ensuring every student understands the problem statement. So before we jump into technicalities, let's understand the problem we are solving. Come with me here. You will see that Miracommerce happened to be an online retail company. Now, this online retail company faces challenges in warehouse utilization, challenges in customer segmentation, challenges in product demand, challenges in other trends and policy implications, product demand and pricing strategies, customer segmentation and service efficiency, warehouse utilization and optimization. We must have a goal because as data analysts, the first approach is always to understand the goal you want to achieve. So what is our goal? Our goal is to use DAX, these DAX functions. Related, lookup value, calculate all, filter functions, iterators, sum x, average x, iterators functions in Power BI. to now provide insights that can influence logistics policy decisions. That's our goal. Now, one thing you must know is that the related function, the lookup value function, the calculate all filter functions, the iterator functions are all DAX functions. So quickly, let's talk about DAX. When we say they are DAX functions, let's set a foundation. What is DAX? And why is DAX important? Now, DAX is an acronym for the full word, data analysis expressions. Data analysis expressions. Data analysis expressions. And data analysis expressions is a formula language used in Power BI. This is Power BI. So you should go over, ensure you have installed your Power BI from the Microsoft Power BI site. So as I was saying, DAX stands for data analysis expressions, and it is a formula language used in Power BI, also used in Excel and other Microsoft tools to create custom calculations and to analyze data. Now that you understand what DAX is, at this juncture, we are now going to apply this into our learning journey. Remember, we are looking at Project Eagle, which is all about leveraging data analysis for policy advocacy. Now, Miracommerce have provided us with data sets. And remember what data set is, a collection of data. So one of the things we must do is to connect the data set into Power BI so we can analyze it. That way we'll be able to provide the insights needed by Miracommerce. So let's go and import it. How do we import this data? Power BI have what we call connectors, which you can use to connect your data into Power BI from diverse sources. So you have to come up here. Here we have get data. Once you open your Power BI, get data on the home tab. So join me, click on that very option called get data. When you click on it, you'll find many options appear. So it's now for you to find out the data set sent by the organization, which in this scenario is Miracommerce. What format was it sent on? What format? It was sent on CSV format. So I'm not going to use Excel workbook because there are different formats data is being stored in. There are some data that comes in SQL Server format. Some data comes in web format, okay, which you have to connect to the URL link. But this very one was sent in CSV. CSV stands for comma separated value, and is one of the most common formats data is being stored in. So join me, you click on CSV. It then brings us to our file explorer. So the file explorer contains different folders where your data set was actually kept as at the time it was sent to you. Okay, so these are the data sets. These are the data sets, and that's what we'll be using based on today's lesson, which is on data-driven policy advocacy in e-commerce logistics. Remember, Miracommerce is the case study we're looking at, Miracommerce. Okay, so double click, then this entire data set will bring them in. So one after the other. The first is customers. I'll click on open. So once you do this, a screen popped up, the preview screen, showing you the data you want to import. So it's just like saying, please cross-check. Okay, so one of the things we do here as data analysts is at this stage, we try to inspect the data if there are errors that could actually affect this data. But that inspecting is not something you just do quickly with your eyes, because there are other errors, cell errors that actually affects your data. And one way to get that done is by first ensuring that the actual data types declared for each column aligns with the type of data each of the columns contain. Yes, this very data set comes with title headers, which are important because I will always tell us in class that when data set comes, it comes in two situations. The situation one is when data set comes with a description of the data it contains. And that description is what we call metadata, which is in this case, the metadata, the descriptions. But however, there are certain dirty that are stubborn dirty issues that will still affect the integrity of your data set. And that's the reason we don't just jump and then click on load. Rather, what do? We use this option called transform data. Where does transform data takes us to? It takes us to the cleaning room. It's a laboratory. We call it Power Query. Where we'll now work on this. It's like your kitchen. You know, kitchen, you go to the kitchen and then maybe you want to prepare a meal. Do a lot of things there, from bringing out the ingredients, washing them, and all of that. So that's where we go to transform data instead of load. Because if you should load this, then you are at risks. What if there are some um, um, stubborn dirty issues that was actually affecting this? There are many of them. We have logical inconsistencies and a whole lot of them. And this is the reason why, we don't just load. We must go to click on transform data. And most of these issues, are things you should always prepare your mind for. So once data have been acquired, once data have been imported, the next stage is cleaning. Here you have to clean your data so it can become information. You must know this because data is not information. It's after data have been cleaned, have been transformed, it becomes information. So until we add information to data, data will remain meaningless. So don't ask me why. Why must we do this? I have explained it. For integrity's sake, there are different tests the data must pass so it can become ready for analysis in a usable form, which is information. So what do? We'll come down, click on transform data. So for the other data sets, we are going to import them here. Okay, so look at the data set area, and of course I hope you know the word queries means data set. So this area is for data set. Okay, so this is our Power Query editor. This area is applied steps area, which keeps track history of all the steps, the cleaning processes you will perform. So here, a quick one on how to check for errors that would actually affect the integrity of your data is for you to first look at the data type icon. Look at this part where I circle. All these are data type icons because we know of the three V's of data. The three V's of data, remember that data first is large, which talks about volume. The second V, which talks about velocity, the fact that data is very fast. And then variety. So this is on variety. Variety talks about the different types of data, how, different kinds of data. Okay. So we are going to start with the data type icon. So look at customer ID. The values we have there, the data values, the data points, the records are numbers, right? So they must align with the type of data that is declared. So I have to click, and that's whole numbers because they are whole numbers. Assuming this column was amount, I would have changed this to decimal number. I hope you understand. Let's go to location. What we have is text data, textual data. Does it align? Yes. ABC is for text. Text, you can see it. Let's go to subscription type. They are all textual data. Does it align? Yes. ABC is for text. Let's go to lifetime value. Lifetime value contain what we call continuous data, data that have decimal parts. And those are what we use to declare those type of data. Amounts, we make use of what we call decimal number. And that's what we have here. So these are ways you check, because assuming what you have here was actually ABC, or maybe a mixture of ABC, that's text and whole numbers, okay, you'll be finding errors appearing. And one way we keep these errors is to go up here to our home tab and then locate this option on reduce rows group called keep rows. Then we'll use keep errors. But in this case, there is no error. So it means this data set is clean and good to go. However, there are other data issues. There are other data issues that we must look at, especially issues of inconsistencies. So those ones have to be inspected also and corrected. So let's go back. We'll come to apply steps area and then cancel these steps with that X button. Now it brings us back here. So we have to look at this. How about in terms of consistency? So one of the things we do is to trim, especially the text columns. We have to trim away what we call extra spaces, white space, because white spaces are powerful issues that can affect, the integrity, the quality of your data. So we'll select, right click on that column, we'll come down, we'll come over to where we have transform. Then we'll choose the option trim. We'll do that in all the columns that contains text. Trim every one of them. And that's okay. So we can now say this is good to go. This is good to go. However, in advanced scenarios, we now have to align this with the requirements of the case study. It's just like you're working with an organization. So that brings us to another test called completeness. Completeness is one of the quality metadata criteria. It's a test you must perform that your data must meet for it to become information ready for analysis. And I always tell us that when we talk about completeness, it's simply asking you a question. Is this data complete? Now, many of us only know how to test completeness by checking if there are missing values across these data cells, the cells in data set. But no, completeness is not just only about the cells. If there are null values, if there are empty values, it's not, or missing value, it's not about that. It's also about if this data set is complete, completely meets with the requirements of the scenario, the project you have at hand. Now let's go back to what we have at hand, so we can look at this constructively. Okay, now when you come here, when you join me here, there is something you should have observed here. There's something you should have observed here. Now, you will find out here, you're going to find out here that we are told here, one of our mission, part of the challenges Miracommerce is having, customer segmentation. How do subscription types and customer lifetime value impact logistics? Now, if you come down, we are told here, question 1, how can we link orders to customer details or policy-based segmentation? Use related and lookup value to join order data with customer information. Now, that data set is not complete, because for us to perform any task that relates to policy-based segmentation, when we talk about segmentation, it's all about grouping, meaning we should group these customers in different groups. That's segmentation. So for us to do this, there must be a column in this customer's data set called customer segments, but we don't have that column here. So we won't say this data set is complete. We won't say it's complete because there's supposed to be another column. So how do you clean this? You clean this one by creating another column, which in that case becomes what we call a custom column. because it was never there. You are now bringing it in. A conditional column, because it's going to be based on conditions. We'll pull out from existing columns. I hope we understand. So you have to pay attention to detail so you are able to figure out all of this, especially when you're working on projects and also working on scenarios. So welcome to Project Eagle 103. All right. So let's bring in the others. Then we are going to do this. So at that point, that's not just only cleaning, it's also transformation, because we are now trying to transform this data so it can be in that shape. It can be complete. It can be ready for analysis. So right click here, new query, CSV. I will then jump in, bring in others table. Okay. So I'll also right click, new query, CSV. I'll bring in products table. Okay. So also right click, new query. I'll bring in the last table, which is warehouses. Okay. All right. So we have everything. We have everything we need. I have everything. So I just want to rename this to customers. So, okay, so let's go over to others table. So others table, order ID, the data type is whole numbers, that's correct. Customer ID, that's correct. Product ID column, warehouse, that's correct. Order dates, data type is dates. Okay, that's correct. Can see it yourself. Dates, that's correct. Warehouse ID, quantity, total cost, decimal. So all of these are correct. So we can also run our check, Control A, keep rows errors. So if there are errors, we'll get to see it. So no errors, I'll cancel this step. All right, let's move to warehouses. Now for warehouses, we have warehouse ID, the data type is correct, whole numbers. We have city, data type is correct, text. We have capacity is correct, whole numbers. We have active status is also correct. However, we are going to apply the trim to take care of extra space issues. So you right click on that column, choose transform, click on trim. Okay, so that part is also good to go. Okay, now let's go to final products. Let's go to product. So on product, we have product ID column, whole numbers correct. We have category, text correct. So we are going to perform transform and then trim. Then we also have unit price, which is also correct. But let's go back. Let's go back to the case study we are actually working on. Let's check something on that case study. Okay, now here we are. Now, if you come down, we have other issues here, which we need to look at completely. So come to number 2, question 2. We are told, what is the total revenue per warehouse, ignoring any filters on the data set? use calculate and all to get total revenue across all warehouse. Now, what this simply means is that we also need to um, calculate the total revenue for all this warehouse. But if you look carefully across the data set, there is no column for total revenue. We don't have any column that contains revenue. There's no column that contains revenue. Please look at it carefully. Do you see if there is any column that contains revenue? Because I can't find any column here that contains revenue. I can't. There is no column that contains revenue here. So maybe if you can see it, that's fine. That's beautiful. But for me, there is none. We only have unit price. There is unit price here. There's unit price, there's category, there's product ID, which I believe you can all see that. Unit price, product ID. Unit price, product ID. Let's go to others table. In others table, what we only have is quantity, total cost. So it means we also have to create another column, a new custom column called revenue. I hope we're together. Let me explain something to us so we can understand this. We want to know the total revenue from each warehouse. What each warehouse, where this the warehouse have been used as the center for all of that. So how much have they generated? How much? But we don't even have any column, we don't have any record that shows us this revenue, these sales. So we have to now calculate it so we can be able to solve the problem. And let me explain something to us. So for those of us who may actually be new to some of these things, you need to understand what we call metrics. METRICS. Now, why metrics? Metrics is here because when we look at the workflow of how to, analyze data as a data analyst, the first thing you have to do is to first understand the goal you want to achieve. After you've done that, two, you are expected to identify the metrics to be analyzed to achieve that goal that you have understood. Your data can be kept somewhere. Yes, your data should have been cleaned and kept. Fine. But you now need to identify the metrics. Because when we look at the whole case study we have here, when we look at this case study we have here, talking about question 2, what is the total revenue per warehouse? For us to solve question 2, we need to first identify this metric called what? Total revenue. So what we analyze is metrics. Let me make this clear because I remember there was a certain time I took some classes. I think that was last year. So when we go to these metrics of a team, especially when dealing with scenarios and case studies like this, I always try to set foundation on data analysis. So we'll always remember. And thank God, almost everyone in this class are Nigerians. Now, you see, every business in Nigeria, I want you to understand this metrics called total revenue, why we now have to compute it. So data analysis demands that you know metrics. You know why metrics are important because they are what you have to analyze to solve this problem. And that's the reason why I will tell us at the end of the day, you'll find out that not every columns in your data set is important. Why? You must look at the problem you want to solve. In every problem you want to solve, you must identify the metrics to be analyzed to solve that problem. What is the total revenue per warehouse? We need revenue. Revenue becomes a matrix that is important. If you come down, we're also told here which warehouses are underperforming compared to others. You will need revenue. It's through the money. We will know. That means those that don't have enough money, they are not performing. So this is an important metrics. This total revenue is very important to whatever we are doing here. It's very important, and that's why we must understand it fully. We must understand it. Must understand it. If you come down again to question 5, what is the total revenue generated per product category? Can you see? Same way as customer segment was, and this is. So I was saying this. You see, every business in Nigeria, from the suya seller in Abuja down to Dangote's empire, wants to make profit. And the key to understanding whether a business is winning, because I will always tell us that one of the key duty of a data analyst is to improve the organization. And majority of the clients you will work with, both remotely, on site, they're always there to make profit. But the key to understanding whether a business is winning or losing lies in data. Specifically, how we as data analysts analyze this data. In this scenario is all about revenue and cost. Go through it. Go through the case study. I've attached it. It's all about revenue and cost. So, but first, if you have not understood what data analysis is, it will become difficult to solve problems like this. So what is data analysis? I will always tell us in class that data analysis is like cooking jollof rice. You will laugh. Why is data analysis like cooking jollof rice? Yes, jollof rice. If you want to cook jollof rice, you first of all start by collecting ingredients, right? The ingredient is the data. After you have done that, what do? You follow a procedure, an instruction. In machine learning, we'll call those step-by-step instructions machine learning algorithm. I hope we are together. You follow a procedure, you follow steps on how to prepare that jollof rice. Those steps is what analysis is. That's analysis. At the end of the day, you have prepared your meal. It's like you've built a model. What do you now do? You try to taste the final dish. That's insight. Now, if this rice is too salty, what do? You look for a way to reduce the salt, right? I don't know how to do that one because when I cook, when it's too salty, I eat it like that. I think someone said something to me a particular time that when the rice is too salty, put oil, red oil. I don't know if that works. I don't know how to reduce salt or put water. If you put water, if it's rice, it will become more soft. So it's even better you don't put too much salt. Then you can put salt later. But if this rice was actually too salty, you have to adjust it. That's decision now you're making. The process of adjusting this rice, that's decisions. This is exactly how businesses also operate. They do the same thing with data. We are dealing on Project Eagle here, looking at this metrics called revenue and cost. We need it. We need revenue. So, but first, what is revenue? Since the scenario is talking about calculate revenue from all warehouse, no warehouse that is underperforming, we need revenue. And if you go through, there is no column where we have revenue. In fact, you will see what makes this interesting. Unit price that we will use to calculate revenue is in products column and product data set. Selling price, that quantity we need is in others table. Yeah? This is problem. Oh. They are not even in the same data set. They are separate. Thank God for those functions. So now, what is revenue? And when we talk about revenue, revenue is the money, the total money a business makes from selling their product or service. Revenue is the total money a business makes from selling their product or service. This is how it is practically. In Nigeria, we know we have a lot of small mama puts. For those who don't know small mama puts, they're all these local food vendor. Maybe you're strolling, you're hungry, you can just stop by, you see their canopy or small shop, you enter, you buy rice and you eat. You know, some place they sell plate of rice, 1,000 naira per plate. You get. Now think about this woman that have this mama put in Lagos or in Port Harcourt or in Abuja or in anywhere. If she sells 50 plates of rice a day at 1,000 naira per plate, her revenue, if we are saying revenue is the total money a business makes from selling their product or service. If this small mama put sells 50 plates of rice at 1,000 naira per plate, what will be her revenue? It's going to be the 50 plates, which is the quantity sold, times what? Price. In fact, let me bring my notepad. We're talking about revenue here. Please flow with me. I want you to understand this because there is a concept we call the concept of orphan data. Orphan data concept. You can make research on it. Maybe something we'll talk about some other day. Now, revenue is like this. The mama puts is going to be revenue equals what? Quantity. Quantity sold times price. So quantity sold is what? 50. Let me bring my on-screen keyboard so you can see it clearly. 50 was the quantity. She sold 50 plates of rice. So that's 50 times at how much? Price. Price at how much? 1,000 naira. So the revenue is going to be what? 50,000. Right? That's revenue. Total money a business makes from selling its product or service. Now, for us to do this, to understand this better, let's also talk about cost. What is cost? Because some business would want you to also analyze their profit for them. So what is cost? Because cost is needed to arrive at profit. When we talk about cost, cost is the amount spent to run the business. For this, our mama put, she buys ingredients. The ingredients can be rice, it can be oil, it can be meat. She will even pay for firewood, right? Or for gas, if she's using gas or kerosene. She will even give money to her assistant. You know, these mama puts, they always have somebody that is also working there. So she will pay her assistant. Maybe the girl that used to serve, the waiter, or the person that used to serve. She will give the girl small money. Let's say at the end of the day, the girl name, maybe her name is Abigail. She gives Abigail small money too every day. At the end of the day, let's say the cost was actually 30,000. That's cost. Because this means this mama put, the money this mama put has spent to run this business is what? 30,000 that day. For the day, the cost is 30,000. Because you also need to calculate or analyze profit. What is profit? Profit is what remains after you've removed this cost that we have here, 30,000 from the revenue. which is 50,000. So that's why we always say profit is what? Revenue minus cost, which is like saying, what is our profit? Our profit is now going to be equals revenue is what? 50,000 minus our cost is what? 30,000. That gives us what? It gives us 20,000. Now, let us imagine this. Let's imagine this our assistant called Abigail stole some money. Or let's imagine rice increased. Maybe the price of rice increased. You know what I mean? Those Nigerians, the price of rice, it used to increase. Hope you know that her profit will reduce. Yes, it will reduce. Because the moment cost increase, it's like saying maybe money was stolen or price of rice have increased. It will make the cost to also what? Increase. If rice increase by, let's say, 10,000 naira, this will change to 40. And all that. If the money stolen or missing was by 10,000 naira, this will also change to 40 and all that. But this will affect, because if anything happened to cost here, profit will also reduce. That's why businesses must track data properly to make good decisions. So someone is now asking you, why does data analysis matter in business? I mean, okay, let's leave this small maput. Let's now go to a large Nigerian company. Example, Jumia. It's just like saying, how does Jumia know which product to sell more of? How do they know which product they need to sell more of? It is by analyzing the revenue. It is by analyzing the costs to see which product make the most profit. So if Jumia now sees that people in Lagos buy more iPhone than Techno phones, they will start to stock more iPhone. This happens even in several, businesses in Ikeja. When you go, you find that they stock more iPhones. You say, why is it that you only have iPhone? You don't have this other phone. It is because they analyze data. So they will stock more of iPhone in Lagos. They will then send Techno phones to smaller towns. That's the type of business we call smart business. So if you're running a business and you can do these things, it means your business is smart. Smart business. So now that you have understood this, we now have to bring this revenue column. Can you see why it's important? It's an important metrics. We now have to bring it into the data set we are working on. We have to add it. Yes, we have quantity sold, which is in, I think it's in orders. Look at it here. We have it here. Quantity sold in orders table. Quantity, these are the quantity, just like that 50 plates of jollof rice. These are the quantity that were actually sold. Quantity sold. Well, we are also given the cost, which is here, total cost. Then let's also check this. Warehouse, we have the warehouse informations. So you can confirm now with me that revenue is missing in our data set. So we must create it. We must create it. We must create it. Unit price is the selling price. So if we are saying that, like the mama put, her price was 1,000 naira per plate, this is that price. So each cloth, this clothing costs this. The unit price is that price. So if revenue, this is how we now know our revenue. If revenue is quantity sold 50 times price 1,000, that means to calculate revenue here in Power BI, we'll first of all find the column that contains all the quantity sold. We saw it now. It's in orders. So it's now going to be, you now come to orders table and say, oh, so that means I will use quantity column, contain all the quantity they sold. Okay. And then the selling price, the price at which they sold it, 1,000, is found in products column, which is the unit price. That's the selling price. So I have to also do what? Multiply them so I can get my revenue. But because unit price is here in product column, then selling price is in another column called orders column. Quantity is in orders column. We are going to make use of this function called related. I don't know if we understand. I just hope we understand. So don't make the mistake some persons will do. Some persons we go and use total cost column in others data set as what? Revenue. Total cost is different from revenue. Because when we talk about total cost, it is the cost incurred by the company. It could be procurement cost. It could be production cost. The same way we saw the mama put cost. That's what it contains. Running the business. Cost spent. Money spent. But revenue is the actual amount this company earned from sales. So what we will do is quantity sold times selling price times the unit price at which they sold it. So if you are now going to use total cost as revenue, you're misdoing. It's not a problem of underreporting or misrepresentation. Yes, because you're misrepresenting the actual sales income. By the time we do it, we'll check. If it is giving us the same, then we'll know that it's now a typo issue. Maybe this was actually supposed to be total revenue or revenue, not total cost. But if not, then it's now a problem of what? Misrepresentation. So how do we provide a revenue column? Enough of this long talk. How do we provide it? For us to do this, don't forget, we will need selling price. That's unit price, selling price per unit from the product table. We'll need this man. Then we will now need orders table from the, we'll now need quantity table, which is this, quantity column, which is this, from the orders table. That's what we will use to build our revenue column. Let's do that. So first, I'm going to load all of this back to Power BI. So I'll come to close and apply. I'll then click close and apply. So that's what you do once you're done importing and cleaning your data. Okay, you close and apply. So let's wait for it to load. Now it has been loaded. You can now view it from your right-hand side on your report view. You see them here, data, customers, orders, products, warehouses. But we'll go over to the second view called table view. This is where we'll now view it, every one of them. So you can see customers, you can also see orders, you can also see products. Okay, you can also see warehouses. Okay, so we want to compute the revenue. So we'll come to others table. We'll then come up and choose this option, new column. That's the option we are going to use, new column. New column. It brings us the bar. So what do we want to calculate? We want to calculate revenue. That's what you put here. The name of what you want to calculate. How do we calculate it? We'll calculate it by first going to bring the selling price per unit from the product table. So we'll write it here. We'll write the name of that table where we want to bring it from. Name of the table is products table. Products table. So we'll say products. We are now referring to product table because we need it. Remember, so it's either you write the name of the table like this, products, or because if you are writing products down as the name of the table, then you have to provide your square bracket. So you can now reference that very column. But instead of doing that, this is what you're going to do. Start by using the quantity column in your orders table. So revenue equals to revenue, what we want to calculate, what we want to achieve. To calculate it, we need quantity, right? So we'll come here. We'll write quantity. Spell it the way it is. Look at it, it appears. So you select it. Quantity from orders table. This orders is the name of the table. Quantity is the name of the column. We said we are going to multiply it by what? By what? We are going to multiply it by the selling price, which is in another table called product. For us to do this, we'll use related function. So we'll say related. We'll then go and look for it, or you type it, unit price. Once you have done this, you close your bracket and then you hit your good mark. And this gives us the what? The revenue. So do you see what I was saying? That there could be other errors. This total cost, look at the values. The value for total cost and revenue is actually the same. That means there was a typo error. But you cannot find this type of error if you don't do this computation too. 109, 109. So this was not even total cost. It was actually revenue. So to avoid issue of duplicates and other mismatching, we are going to delete this total cost. We'll right click and choose delete because it's the same thing. So we'll say yes. So we have our revenue, which we computed, and this. So if you look at this revenue and the formula, what this formula have done is that we have just multiplied the quantity sold by the corresponding product selling price using a function known as the related function. Now, this related function is the function that fetched the value, the unit price value from the other table, which is called product table. I hope you understand this. Now that we have our revenue, we can also find the total revenue for each warehouse. It's like saying, okay, warehouse 1, warehouse 2, how much did they generate? How much sales did they make? Look at, we have 1, 2, 3, 4, we have 5 warehouses where all these products were sold from. So how much did they make? Remember, we are told to also check the underperforming warehouse and all of that. So we can also now create for total revenue by what? Warehouse. This is where we'll now use this function called calculate, the calculate function. Let's try it because we want to get the total revenue per warehouse. Let's try it. Total revenue per warehouse. We are going to do this. We'll come, click on new measure. We are going to put down here total revenue, because that's what we want to find per warehouse. Which is going to be equals calculate sum our revenue, comma. Now, while we are doing this, we want for only warehouse, right? So we'll say all. We use all except others, comma, warehouse. We'll look for our warehouse ID. Sorry, is in warehouse, houses, comma, warehouse ID. Bracket close, and bracket close, and then bracket close. So we have to close this bracket after revenue. Okay. And then I think this closing bracket is much. Okay. So we execute. All right. So you can see we have created total revenue per warehouse. Look at it here. So this will make more sense when we visualize by going to our report view using our card visual, the one that has 1, 2, 3. So we can click on total revenue per warehouse. You can see it. The total revenue per warehouse is what? So I will always tell us, go to format your visual after selecting the card, come to call out value, scroll down, where you have display unit, change it to none. So you can see the total revenue per warehouse is actually how much? It is 148,000. 148,489.87. That's the total revenue. I think instead of using per warehouse, let's correct that. Total revenue for each warehouse or warehouse, total warehouse revenue. Okay, so total warehouse revenue. So let's try something. Let's say we add up a slicer, and the slicer contains all the warehouse. So we can also change the format of our slicer. Okay, so if you can look in here, I hope you can all still see my screen. If you can check in here, you will see what we have here. Or we can even, let's use a table instead of this. Okay, let's use a table instead of this. Okay, so if you look closely on this table, you'll find out that this table contains the warehouses that we have. So if this is total warehouse revenue, that means if we are clicking on saying, okay, let's view the revenue for each warehouse, let's say for the first warehouse, you can see that the first warehouse, the revenue was what? 3892.94. So this is the reason why if we are leaving the previous description, total warehouse, total revenue per warehouse, it will have now matched, right? Because for warehouse 1, the revenue is what? 3892. For warehouse 2, the revenue is what? 36. For warehouse 3, the revenue is what? 18. For warehouse 4, the revenue is what? 34. For warehouse 5, the revenue is what? 3005. So where we are now saying that, let's know those warehouses that are underperforming. What do we now mean? How do we do that? We now have to use comparison visuals because that's to compare. We'll know. So maybe we'll make use of this stack column chart. Then we'll select our warehouses and the total amount, and it gives us this. So you can now see clearly that if there is any warehouse that is underperforming by revenue, it is warehouse 3. In fact, we can go and make this easier by adding what we call labels. So turn on data labels like this. Then we can also see it clearly. We can also do change the display values to be clear. So where we have our, let's go, value. So we can change the color to black. We can change the display units to none. So you can see it clearly now. Okay, you can see them. So warehouse 3 is this, just like that. So another thing we can do here, another thing we can also do here is to run the analyze to find where the distribution is different. So right click, choose on what? Analyze. You can also do comparisons. Maybe you want to do this versus the next and all that. But summarize or analyze. Okay, let's go to summarize. If I'm summarizing this, there are certain things we need to turn on, especially this co-pilot feature. So we need to sign in to Power BI service. So just use the analyze just to get your description on that. If you want to explain the increase, you want to explain the decrease and all of that. So you do it and you wait for it. So you can see what we have here, that the analysis of that there is an 89.53% increase in total warehouse revenue between 3003 and what? 3004. And you can see it here. And also the cities, you can also see that Berlin accounted for majority of the increase among city, offsetting the decrease of London. You can see what we have here. So you can also move to your next. You can see London, New York, how they all connect. This very one is just giving you that breakdown. Then also can see the warehouse between Berlin and also London comparisons, since both of them, and this accounted for the lowest. London was the lowest, 3003, the warehouse in London. Then Berlin is the highest. So we are now comparing between the highest and the lowest. Then can also get it here, the highest and the lowest. You can see what we have here. Okay. So you can also decide to add this to your page by clicking on that plus sign that we have there. Yeah. So you can add it to your page. All right. So we'll have it in our page. Look at it here. So this is what we'll do. We're going to reduce this, and then we're going to increase this. So total revenue. So this is very important because at the end of the day, this gives us insight into the highest performing warehouse and the underperforming warehouse. So what we have made use of, we have made use of related for our revenue, we have made use of calculate. So you can see how it is here. Makes sense, right? So let's make some adjustments here on our background. So let's make some background adjustments. Remove. Click on the 3 dots to remove it. Okay, so we'll come back to format visual, canvas background, change it so we can use blue. Is blue going to work out? We can use black. Maybe we'll go with brown, like this. Then for it to be transparent, to be displaying, come to transparency, reduce it. Okay, so we can have something like this. Right, so this is the total warehouse revenue and you can see the revenue by each warehouse. Okay, and you can see comparisons between London and Berlin, which is overperforming and underperforming, performing and in terms of performance. So you also be able to see all this. Okay. So now that we have this, there are other things you can now do. You can also do your total revenue by product category. So we can name this page. So double click on it. We can call it revenue warehouse. Okay. Then we can go to the next. That's like warehouse analysis or visual, whatever you want to name it. So we'll go to page 2, new page. This one, we can focus on product category. So to do this product category, we also have to go back and compute our total revenue by category. Now, for us to do this, we'll make use of this very function called iterators. We'll be using this iterator called SumX. So please flow with me. After this practical, now you now see the explanation of them, though you now apply it to know why we are using it. So we'll use SumX for it. We want to know the total revenue by product category. So now that we are here, let's go to the column that contains it. That's product. We have categories. So we want to know how much have we made from each of these categories. So we can provide insights for this company, Miracommerce, based on this. So what do? We'll come, click on what? New measure. Because they are all single results. Measure, single result, single calculation on the fly. Now, what do we want to calculate? What do we want to calculate? We'll come here, clear measure. We'll write the name. Total revenue. Our what? Category. Equals, we'll use this function called SumX. We'll now mix it with related. Related table. Now, this is where it becomes interesting. Related table. Remember, we're looking for total revenue. Where is revenue? Revenue is not in product table. It is in others table. So we'll relate it to the table where it is. So we'll select the name of the table, which is others. Inside others table, we are relating it to what? So you close it, you say comma, we are relating it to what? Revenue. So you type in revenue, which is this, others revenue. You close your bracket. You click on the good. The moment you do this, look at your data area. You now see we now have total revenue per what? Category. So where the company is saying, please, we want to know our total revenue by categories. You now do it here. Visualize it for them. Total revenue by categories? Yes. Select your star column chart. Expand. Or you can select the first type, whatever type you want. Then you come down and click on what? Category. And what? The total revenue by category. So can you see this? Awesome, right? Health and beauty is the most performing category, followed by clothing, followed by what? Furniture, followed by what? Home appliance, followed by what? Electronics. And we have been able to uncover this very insight here. So what we'll do here is to come down, change the bar colors. So all these are things you can do later. So we'll change the color of the bar to something like this. Okay. Then you take your time, increase the borders, increase the size. So don't forget to add your data labels. Okay. So, and also come down to your values. Also make sure you change the values, make it bold, increase it, then change the color of it to black. Display units, change it to none. So you have it this way, the entire amount. So you can see that for revenue per category, health and beauty is the highest. So those are the, you can increase them at the X and Y axis. Okay, you can also make it bold. You can also change the color, something like this. Then you can expand this. Remember, make it simple. Understandability is very important. All right, so this is now the total revenue per category. So we'll come to canvas background. We're going to change our background to this. Then we'll come down transparency to this. So these are total revenue per category. So there are a lot of adjustments you can do to this. There are a lot of adjustments. Okay, so this is that. If you don't want the grid lines, you can also take it off. So this becomes our total revenue by category. Now, if you go back to the case study, we talked about underperforming warehouses, right? There is the aspect of underperforming warehouses here. Let's go over to it. So we are told about underperforming warehouse. Okay, we have something here. What is the average order value per customer? What is the average order value per customer? Now, to get the average order value, we have to do some dividing. Okay, we have to do some dividing. We have to do some things to divide to be able to get the average order value. The average order value. Let's try that, right? Let's try that. Let's try that. So we'll look at this using what we call the average X. But before this, let's go to the top where we have some areas like this. Which houses are underperforming to others? That's underperforming warehouses. So for us to do this underperforming warehouse, we also have to make use of some of these tools. Okay, both your calculate filter. In fact, let's use average X. Let's see what we can do here. So we are going to go back to data table view. We are going to create a new column. So let this column be created where we have our warehouses. So this will affect warehouse. Underperforming, right? So we use new column. Now in our new column, what do we want to calculate? So we want to calculate underperforming warehouse. Remember, what we want to calculate is what? Underperforming warehouse. Underperforming warehouse. So we'll say underperforming houses equals there's a function we use called var. I'll tell us why later. So var average revenue equals, let me bring up my on-screen keyboard so you see I'm doing it. So var average revenue equals average X. Remember, it's one of the iterators. Average X, bracket open, all function, all, bracket open. Now, this underperforming warehouses, we are using revenue, don't forget. And revenue is somewhere in orders table. So we'll now say all orders, everything in orders table, bracket close, comma. We want to sum the revenue in that table. So we'll bring the sum function. We'll then reference the column that contains revenue. Then we'll close our brackets twice. Once we have done this, let it return what? We'll use the return function. We'll say return if. So now, how do we now indicate a warehouse that is underperforming? So we'll now say if, that becomes conditional. So there must be a condition a warehouse must meet for it to be what? Performing. There must be a condition for it not to be what? For it to be underperforming. So anything condition, you work with if, right? So you say if sum, you look for the column that contains revenue. That's what I brought. Bracket close. Less than, if it is less than what? The average revenue. comma, let it be called underperforming, comma. Otherwise, let it be called performing. Let's say performing well. Bracket close. This will work, right? I think there is an error message talking about DAX bar average revenue. Syntax for is incorrect. Let's check where we made a mistake. Okay, let's execute this first. Let's see what we can do if it's wrong. Exactly. So can you see we're having performing well? Despite New York is inactive, but on the performing warehouse, we're having performing well. So this, we can call this instead warehouse status. Let's call it warehouse status by performance. Okay, so this shows that all the warehouses are performing well. All the warehouses are performing well. All the warehouses are performing well. Can we take a look of it? All the warehouses are performing well. Okay, so I don't know. I believe you can do something on this. I believe you can do something on this because it's very important you are able to do this. It's very important. Now, before we wrap up this, let's go to the case study. We are told here in question 1, how can we link orders to customer details for policy-based segmentation? Now, for us to do this, we are told to use related, use lookup value. But first, like we said, there must be a column containing what? Customer segments, customers groups. So we are going to do this. We are going to go back and then classify all our customers. See all these customers here. Customers table is here. It has been sleeping. Oh, yeah, wake up. So we are going to classify all these customers into groups. That's customer segments. Customer segments are groups, customer groups. So we'll have those groups we call high value customers, mid value customers, and low value customer segments. Now it's going to be based on their subscription type and their what? Lifetime value. Lifetime value is the value we have put in, the expectation we have put in terms of value from each customers. I think I explained this in one of our classes. So what do? We'll come up, click on new column. What do we want to calculate? We want to calculate customer segments. So we'll say customer segments equals what? Switch. We'll use a function called true. I'll explain all these functions. Then you know why we are using it. So true, comma. Now, remember, we said we want to create customer segment column by classifying our customers into high value, mid value, low value, based on subscription type and lifetime value, right? So this is what we do. We say comma, subscription type. So we have to reference the customer table. So we select subscription type. We'll then capture all the subscription types that we have. Let's start with the first one there. We have premium, we have enterprise, and all that, right? So let's start with the highest. I think the highest is enterprise. So double quotes because it's a text. We say enterprise, double quotes, and then we say customer again, and customer like a lifetime value. Don't forget. So customer's lifetime value. Now we are going to say greater than 4,000. So any lifetime value that is greater than 4,000 will be what? High value. Anyone greater than that will be high value. Double quotes, comma. We'll move next. Customer, subscription type, equals this time around the next is a premium, right? That's the next subscription type, premium. So if it is premium and customers lifetime value, let's say if the lifetime value is so 1,000, then let this be what? Mid. That's between 4,000 and 1,000. Let it be what? Mid value. Comma. Customers subscription type equals we have basic subscription type. Now basic subscription type and customers lifetime value. So less than or equal to 1,000, comma, let it be called low value. So otherwise, if there is anyone that is not in that any of these category, let it be called unclassified. So we are going to close this bracket against the former. So that's what we are going to do. So what we have written here, this DAX we have written here is now a data analysis expression. You know, I used to call it a sentence, a data analysis sentence or expression that we now go and classify all our customers based on their subscription type and their lifetime value. It's just like how company will say, okay, can we classify our customers based on their spending history? It's things like that we are talking about, based on their spending history. Spending history. So I hope we understand this. By the time we have done this, all we have to do now is to then execute by clicking on that group map. Now, what do you see? We now have our customer segments created. We have those who are low value, we have those who are high value, we have unclassified, we have low value, we have low value, we have high value. So I think this unclassified, let's get rid of it. Don't think it makes sense here because we are working with 4,000 in between this. So I think this is something we have to look at here. So we are saying enterprise. Okay. I think this is okay because all enterprise who bought above. Do you understand this? All enterprise. Let's execute this back. Leave the unclassified. So remember, we said all enterprise. Who all those customers who actually subscribe to enterprise subscription and their lifetime value is above 4,000. Should be what? High value. So do we have anyone? Do you have anyone, any customer that bought enterprise and is above 4,000? We don't have. There is nobody. So what if we have changed this to 3,000? I think we'll not have the issue of, let's make it 2,000 of unclassified because that amount was too high. Okay, good. So you can see unclassified is still there, but is lower because these two conditions have to be met. You must have bought enterprise and spent above 2,000 to be a high value customer segment. Like this person here in US, customer ID 1002. Can you see it? Enterprise subscribed on, spent above 2,000, so person is high value. Look at the next person, 1,000, below 1,000. Can you see it? So look at those who are mid value. Do you have any mid value? Yeah, this person mid value. Okay, this person mid value. But this person bought premium. So flow with the conditions, premium, low value. Then those unclassified are those that were not in any. Okay, so this is the segmentation we have just done. This is the segmentation we have just done. So I will be looking forward to everyone to practice this so you can do this, so you can be able to. So I want to believe this is something. I want to believe this is something you can all do. When we are practicing, please, if you have any question, don't forget to keep me updated on it. Then we were told to do something here. Told to also told we are told uh, what is the average order value per customer. So one way we can also do this is to, since you're in customer table, the order value per customer. So let's go to our table tools. So let's click on new measure. Or we can still use let's see, new column. So we are looking for average value or average order value, which is going to be divide some revenue. Revenue is in our orders table. Bracket close comma. We are going to count it. So we'll make it a distinct count. So we'll say distinct count. Our customer ID is under customers, right? So let's see where it is. Okay, let's use, since we are talking about orders, so we'll use customer ID in orders table. Bracket close. Bracket close. Let's execute this. Let's go have it. So this becomes the average value for our customers. So what we'll do instead here is to create it as a measure. We're going to create it as a measure instead. Single value. So I'm going to delete this average order value column. So this will be new measure. Okay, so we have now created our average order value. So the good thing here is the fact that we have been able to create our customer segments, which is very important. Also the works we are having there. Okay, so all these built-in functions are important. Okay, they are all important. So I don't know. Let me explain something. Let me explain something. Yeah, let's go to each of them. Some of them we have already done. So like the customer segment, you can see this one is more broad. Now, this is a DAX function we have been talking about. Here we made use of the switch function with some logical patterns to be able to create this segmentation. Now, this switch through you're seeing is a pattern that is common within this DAX domain. Now, what it does is to allow you to be able to evaluate multiple conditions in order. If the customer's lifetime value, here we're saying if the customer's lifetime value is less than or greater than less than 1,000, we selected the code words. You can see. Or greater than 1,000, let it be called mid value. If it's less than or equal to 1,000, let it be called low value. If it's between 1,000 and 2,000, let it be called mid value. If it is above 2,000, let it be called high value. Those ones are labels. Mid value, high value are all labels. Labels, labels, labels. So if we must be able to analyze other trends, tailor marketing strategies, or even support policy advocacy, which we're actually looking at here. Yeah. These are certain things we actually have to look at. Because the goal is to show which segments are driving revenue and which segments may require policy intervention. So work on these aspects, try to see how you can create this so you can be able to understand this works. Then we also did something on the this very measure we created called total revenue per category using SumX. Okay, so SumX is an iterator. Now you are to use SumX, you are to use iterators when you need calculations that depend on row level operations, row levels, measures, because they give you flexibility to perform your aggregations that other simple aggregation functions cannot do. I hope you understand. We're looking for total revenue for each product category. SumX now went over the product table here to multiply the unit price. See this one? Let's go back to that. Okay, okay. So it went to the others table because this is total revenue by category. Please, there is an error here. Total revenue per category. SumX related others revenue. Total revenue by category. Okay, okay. So another way we can do this to be more clear, let's not use this method. Let's not use this method. So this is what you do. This is still correct because here we are relating it to that revenue column, which is in others table. But instead, let's do it this way. Let's say SumX products from others product table. Let's pick the unit price from this table. So now we want SumX to go and multiply the unit price by the quantity sold, which is in another table called others table. So we'll now use related to be able to link up to it. So say related. In others table, we have quantity. So we are looking for quantity. So if this is not working, let's say if we use related table, others, comma, and this give us a quantity, no. Okay, so this method I wanted to try, let's leave it out of this. Let's go with the other one, which we made use of our measure to be able to do this. Okay, so you can go with this other method there. I think this one will be more straightforward. Just use your SumX to compute what you have there and then get it done. So we also did something on the average. Where is it? This is our average order value. Average order value. So we're actually told that our average order value, we should use average X. So you can also try using average X. You can also try using average X. Let's try that instead of this divide. Now we'll say average X customers, comma, calculate. sum our revenue. Yeah, you that should be in orders table. Bracket close. Okay, so after your average X customers, calculate some orders. So we have to close one more bracket here. So let's execute. Let's see if we can get same thing here. Okay, so this using average X to calculate average order value per customer. And this is the average order value. This is the average order value. So let's go to our, let's create page 3. Let's say this is, let's just call this customers table. Just want to test run this. So this is our card visual and this is our average order value. So the average order value is this, which we can go change the call out value to none. So 30.40. That's 3,030.40. So this is the average order value. And it was also stated as a requirement here. What is the question 4? What is the average order value per customer? Use average X to calculate the average revenue generated by customer. So what we have just done here is this. This is the answer to that question. Okay, so this is the tax, same tax for it. So this is what the scenario is about. We want to know the average revenue generated by each customers. And this is how average X works. It went to the table of customers and then calculates the total revenue for each customer and then averages the result. This is the result. I hope you understand this. This becomes the result. So both average, this average X and some X that we have also used today, they are what we call iterators. If you look at your curriculum, exploring iterators, they are iterators. What are iterators? Iterators in DAX are functions that work on row by row basis. So any function that, there are functions that work on row by row basis. Average X went to do the work. It went to look for all customers. It was not a small task. So anytime you hear iterators, always remember there are functions that work on row by row basis to perform calculations. When we say iterate, it's the same thing as loop. They iterate each, they look at each to check, can we average your result? Can we average your result against the revenue? You understand? They loop through each row in a table and then aggregate the results. Those type of functions, we call them iterators. That's what they do. That's what they do. Which one have we not talked about? We're also, okay, lastly, we're also talking about this very function called calculate all and filter functions. Now, let me tell us this. One of the pillars of DAX is the calculate function because it allows us as data analysts to modify the filter context of our calculations. This is very important when you want your measure to ignore certain filters or apply specific ones. I used to tell us now, it's like saying, okay, since we have the total revenue for all the locations, what if we say, okay, how about total revenue for only USA? It means you're ignoring the filter. Do you understand? You're applying to specific direction. You're focusing on a particular location, not all location at that point. That's calculate. Let me give you a scenario now that is in line with this. Let's say we want to calculate the total revenue across all warehouse. We did something like that before. But this time, we want the total revenue for all warehouse. This is what we'll do. We'll come, to our table tools, new measure. The name we're going to call it will be what? Total revenue. All warehouse. Now, this will be equal to what? Calculate. Sum. Want to sum. Where is our revenue? Is in others table. Now, we want all. This is where all comes in. This is where all comes. Because we want to calculate all revenue. Please flow with me. We want to calculate all revenue. Please flow with me here. We want to calculate all revenue across all warehouses. We don't want any current filter. We want to focus. We say calculate, sum, orders, revenue. We'll close the bracket. We'll say comma, all warehouse, all. We'll then go and look for the column that contains warehouse. This is the table. Close bracket. We execute. So we now have total revenue, all warehouses. So we can come to our report view, create a new page, call it warehouses. Okay, we have one there already for warehouse. Okay, so instead of even doing this thing, so let's see if it will give us the same thing with this previous one we did. So we're going to create another card visual. Then we'll look for that new measure, total revenue. No, it's not this. It should be it. No. Let's go approve. Okay, this is it. Total revenue or warehouse. So this is our total revenue or warehouse. You can see it's still the same. By the time you change this display to none, it will give you the same. So 148, 148. So let's take note of these things. Very important. Okay. Now, this is where it becomes more interesting. We can calculate using all, and we can also calculate using theta. That's what this is talking about. How to calculate using all and how to calculate using theta. Now, for theta, it's just like we are told here in the case study that we should identify question 3. We have done all. Okay, all says, look at question 2 says, we have done question 2 just now. Question 2 says, 2 was saying using calculate all and theta function. Now question 2 says, what is the total revenue per warehouse, ignoring any theta on the data set? We have done that. Now, use calculate and all to get revenue across all warehouse. That's what we just did. This is the revenue across all warehouse. We're told to use calculate and all. That's what we did here. Calculate all. That's what we did. To get what? Revenue across all warehouse. Now let's go back. Question 3. Which warehouses are underperforming compared to others? Use calculate and theta to identify underperforming warehouse. Now this is a scenario where we have to identify underperforming warehouses. For us to identify this, we have to compare performance against the overall metrics. Remember, we talked about metrics. To do this, we'll use theta function within calculate to create a condition that we go and select only those warehouse that meet our criteria. I hope we understand. Let's try this, then we'll be rounding up with this. This is what we'll do. We'll go back to table view. We'll then come and then click on new measure. What do you want to calculate? Underperforming warehouse. The previous time I did it, I used other methods. So now we are using the method we are asked to in the case study. So underperforming warehouses. Revenue. Now this is equals our calculate sum, the column that contains revenue, that's other stable, that's it, column, bracket close, comma, filter, because we are told to use it with filter. We want to filter what? Warehouses, comma. Now in this warehouse, we'll focus on the capacity this time around. So what that means is that any warehouse whose capacity is below, let's say, 5,000. So in fact, let's do this inside the warehouse table. So let's go down to warehouse table so we can see capacity well. So we are in warehouse table now. These are all the capacity, 5,000, 8,000, 1, okay? Because now, remember the other time we did warehouse titles by performance, by revenue they generated. But based on the case study is not talking about revenue. It's talking about capacity, that, okay, if by revenue all of them perform well, how about by capacity? So we are now to use calculate and filter. New measure. So we said any warehouse whose capacity is below what? 5,000. Now we have to bring our condition. Okay? You have to bring our condition for this with a comment. That's what I'm trying to do here. So I will say underutilized, right? If capacity is below 5,000. That's all I'm concerned about. I will then close my bracket and my brackets and my brackets and my brackets. What's going on here? Oh, sorry. This is a comment, so my brackets will stop here. Let it stop here. Okay. So let's execute. Let's see what we have. Oh, we created this as a measure. So we have to create it as a column, not a measure. So we have to delete that measure we created there. That's why it's telling us we have the same name. But this is underperforming. So let's go and delete the measure. The measure is somewhere here. Look at it. This one. This underperforming warehouses, blah, blah, blah. Let's go and delete it. I think this is measure. So we'll click on the drop down and then we'll click delete from model. Exactly. So let's do this. Execute. Okay, so underperforming warehouse revenue. Is this supposed to be revenue? What we are doing? Underperforming warehouse is, sorry, underperforming warehouse revenue. Calculate some orders revenue. Filter warehouses. Okay, capacity is less than this. Okay, so okay, so this is what we are doing here is the revenue of the underperforming warehouses. So let's take it back to measure. Let's take it back to measure. That's actually what it's supposed to be. Sorry, I did not I skipped the what we are trying to look for. So we put into consideration the capacity. So for those warehouses, new measure. Okay, so what we are looking for actually, was this. Let's go to the question, the problem statement. We are told which warehouse are underperforming compared to others. Use calculate and filter to identify underperforming warehouses. So what's happening here is that we want to find out those warehouses that are underperforming. Now, only those whose capacity is below 5,000. Are you saying that we now filtered it? We filtered only those by capacity, not everyone. That's where filter comes in. I hope you understand. So if we go here now to warehouse, we can now include a visual here. This is what we can do. We can say here is warehouses. Okay, so underperforming warehouses. Okay, so this we do. This is underperforming warehouses revenue. Yeah. So this is the revenue of all the warehouses that are underperforming. All these those warehouse that are underperforming are those warehouse whose capacity, what they actually were able to accommodate, were below 5,000. So what is the revenue of the underperforming warehouses? That's what we are looking for. This is their revenue. Go and put it together. Go and add the revenue of those warehouses that are below underperforming warehouses revenue. So all those warehouses that are underperforming, what is their revenue? How much did they make? Now, for a warehouse to be an underperforming warehouse, you must be a warehouse that has capacity less than 5,000. So that 18,000 we are having was added by adding all those warehouse whose revenue, those warehouse that are under, the capacity is under 5,000. So it was not a small work, calculate and filter did. Because, okay, if we say where are those warehouse that their capacity is below 5,000, look at them here. London, that's warehouse 03003, followed by, in fact, it was only this. The rest are above. So that means the 18,000 is the revenue of only the warehouse in London. This is how we'll now confirm it, because we did something before about London, right? Which is 3003. Now this is how we'll confirm it. Look at London here. What's the total amount of London? Is it not 18,275? Now compare it with warehouse revenue at the top. So that tells us that the underperforming warehouse is London. And even from when we did total warehouse revenue by warehouse ID, it was London here. That was the lowest. So it's not like we, at the end of the day, will now tell this organization, please shut down London warehouse. It's underperforming. In terms of capacity, it has the lowest. In terms of revenue it was able to generate, it has the lowest, 18,275. And our analysis have also revealed that. So instead of carrying calculator to now go to revenue and start selecting all the London revenue and add, you can see what we have done using our visuals. So if there's anything I will tell you, let calculate function be your best friend, especially when it comes to modifying your data. What data is considered in your calculation? Let it be your best friend. Why? Because you can see it has allowed or helped us to be able to answer targeted questions. Questions like, what is the total revenue if I should ignore the current filters on warehouses now? What is the total revenue? Do that as an assignment. Do all those things as an assignment. So this is how we use the calculated. Is how we do all this. Very important. We have been taxed here as data analysts at Mira Commerce that we should influence policy decisions by uncovering key insights. That's the scenario. Uncovering key insights. uncovering key insights in e-commerce logistics. And we're told that, like, you can see them, identifying underutilized warehouses, determining which customer segments are most profitable. That's it here. So if we now have customer segments done, how do we now determine which segment is most profitable? Let's go and do that one. To know which customer segment is most profitable, we can go to our customers here and then run a visual. We'll call this, here is our customers table. These are customers table. We have customer segment here, right? So we can say customer segment and what? Revenue. Revenue is in orders table. Okay, so we can use our pie chart for this. So which customer segment is most profitable? Low value. Look at low value is most profitable because this is pie chart that visualize data using slice, the larger side. In fact, let's use our stack column chart. Low value generated low value customer groups. Those customer groups that are low value generated the highest revenue. So low value is most profitable. I hope you can see that clearly, that they generated 71,000 low value. They generated 71,000 low value. Can you see it? Display units. Let me change it to none. Low value, followed by high value, followed by mid value, followed by unclassified. Now, we can use even our line charts to visualize this. Low value. This is our average order value. And this is our the order. So these are our revenue, sum of revenue by customer segments. Then this is our average order value. Okay, so you can see the trend, the movement, that the most profitable is low value. I hope we understand this. Low value. So the fact is we have multiple data sets. We have customers, we have orders, we have products, we have warehouses. These are multiple data sets. The customer's data set contains details such as customer ID, location of customers, subscription type, lifetime value of customers. That's what we have here. Then we created customer segments to classify our customers into groups. Look at the DAX formula we used. Look at it. We were also given, Miracommerce gave us orders table, and the orders table contains features, which are columns, capturing order ID, customer ID, product ID, warehouse ID, order date, quantity. There was revenue before, but there was a typo error, which was named total cost. And we did our own revenue here using this DAX formula, and we're able to identify to avoid misrepresentation or misreporting. I hope we can see that. We're also given another table called product table, which contains product ID column, category column, unit price column. All these are just details about the items. For warehouse, giving us information on the logistics aspect too. The warehouse ID, the city, the capacity, the active status, and the warehouse status by performance. This was majorly by revenue. To know those who are underperforming or performing well. But I want us to take this away, or maybe we can leave it Since you are saying we did this by the average, that means everyone met the average. But if we go by the revenue, the underperforming actually had, which underperforming in that case we said is by capacity. That London had the lowest capacity, meaning it was underperforming, and that's it. Inactive status, meaning this for now is not active, but the fact that they also generated during that same period means they were used. So the only twist here was that first, when we started, if you check your data set, your customer's data set does not include customer segment column. So you have to compute it because it is very important for policy-based segmentation. And today, we have learned how to create calculated column using DAX. We have also explored other key functions. Now, before we round up, lastly, let's look at the last function we have not looked at, which is known as joining data. Because we have talked about iterators, we have talked about calculate and all and filter. We have not talked about this, though I used it. Now let's talk about it. Joining data with related and lookup value. Now, before you start to create new columns or measures that we have been doing, it is important. I had to start from the end point to come down so that you now understand why we are doing some things we did, especially why I made use of related in the places that I made use of it. Now, before we create new columns or measures in this feed, it's always important to understand how our data sets connect with each other. Now, in Power BI, we call this relationship. And you must know that relationship in Power BI allows us as data analysts to link tables together so that we can pull in additional information easily. And this is where this man called related comes in. What is related? What is it? Now, related function is a function that fetches a value from a related table. Why do we use it? We use it so we can bring columns from another table where a relationship already exists. Let's look at an example. Let's go to the orders table, everyone. Come with me to the book of orders. Come to the book of orders. Now, in this orders table, you may want to show the customer subscription type from the customers table. Please flow with me. In orders table, there is no subscription type of customers. Is it not? Look at now. No subscription type. But what if we want to bring subscription type here? What if we want to show it here? Whereas this subscription type belongs to another man. It's just like, let's say orders table is a family. We want to marry a wife. And this wife is the daughter of another family. You know, when the wife is married, it's like bringing the wife to this family house. What we will use is related. Why? Because related function is that function that fetches a value from a related table. First, the tables are related. How are they related? Look at the customers table. There's common identifier. We have customer ID here, meaning there's a family friend already from that family. So they're already related. It will not be difficult to marry a wife from their family. It's just like their brother or one of the family member there is my family, is my friend. So it's related. I remember telling some of us that the difference between related and lookup is that related is when there is something, there's a relationship. Lookup value is when there is no linking, nothing relates us with that family. That's where you use lookup value. So if in this our order table, there was no member, no representative of the customer's part, we will ignore. I hope we understand. We'll just use lookup value because at that point, there is no relationship. But yeah, there's a relationship. So this is what we'll now do. Remember, we use related to bring in columns from another table. where a relationship already exists. The fact that we have a foreign key, a foreigner in our order table called customer ID means what? It simply means that it's a relationship. We call this parent to child relationship. There's a link. We can now have information we need. So here, we'll now write it. Come here. Remember what we want. We want to show the subscription type from another table called customers here. So we'll come to table tools in table view. We'll click new column. What do we want to do? That's what you will change as the name. We want to bring in subscription type. So say subscription type equals what? We'll use related. So say subscription type related. Customers. Look for the subscription column. You see, when we did it, it is going there already because we have one of them as friend in our house. So you can see. And now execute. Simple. Do you see we now have subscription type inside order table? That's the work of related. We have now identified that every customer order ID here was for basic. Order ID 4131 was for subscription type basic. Order ID 4042 was for subscription type enterprise. Order ID 4145 was for premium. What have we done? We went to bring in a column from another table. How was this possible? It is because a relationship already exists. Why? We now use related. So related is a function in Power BI that fetches a value from a related table. This table and customer table are related through this man, customer ID. Lastly, before we close, let's talk about the lookup value function. This one we now call lookup value. This one, lookup value function. What is this lookup value function? Now, lookup value function is a function to search a table for a value based on one or more search conditions. Lookup value function is a function to search a table for a value based on one or more search conditions. Before I said there is no relationship at all. Yes, that's why we use it. We want to join something when the relationship is not established. But we want to still retrieve that information we need. But this time around, there is no relationship. It will be difficult. How do we penetrate into that environment? We don't have any idea of it. This is it. Let's use lifetime value here. Let's say we want to go to customers table to bring lifetime value of the customers here. You know, customers table have lifetime value. This is it. Where is that customers table? Yeah. This is customers. Okay. Are we in customers? No. This is customers table. Can you all see lifetime value? The LTV. Now, imagine we want to pull lifetime value of customers from customers table into orders table without any relationship. That means there was no relationship at all. So let's go and disconnect the relationship. Where is orders? This is orders. I will delete customer ID. Delete. Now that I did it, notice subscription type have been affected. Why? Because this man related subscription type was only possible to come here because we have friends who we are related with them. Now that there is a problem with we are no more friends with them, it's not difficult to marry their daughter. Problems have occurred now. Can you see? We have taken away that guy from the family. The daughter too have disconnected with us. Can you see? It's now showing error. But we are saying, what if we still want to bring this man? Okay, let's say this same man. But this time around, we want to bring him. But since there is no relationship, I now said, what you will use to bring this same man, now that to marry their daughter, even if their brother, who is my friend, and I had issues. We no longer talk to each other. Yes, I should still be able to marry his sister. Despite that, we don't connect. But at this point, we will not be able to use related. We'll now use this other function we call what? Lookup value. So come here. So you'll be shocked. Ah, who is this guy? So after we have disconnected, he was still able to come to our family. We'll now use it. We'll say name first, subscription type equals lookup value. This is the function. We'll go back and look for him. Subscription type. Comma. Customer's table. We'll go to the customer's table and then pull whatever I want to use here. So we'll try to still want to connect again quickly. Once we have done this, we'll now write our orders table again and then see how we can connect it also. Oh, let's see. Let's stop here. Let's see what we can do here. So let's first try this. Let's see what we can do here. Bracket close. So we are being showed an error message, right? It says what? There's an error message here. Okay, so let's execute this first. Let's see. So we are still having error. We are still having error, right? I hope you all can see my screen. We are still having error. So this is what we'll do. Okay, let me think. Something is wrong with this very table. Come in. It's going to be affected now. Let me go to new query. Let's go and bring in a new one here. Edit query. Text/CSV. This is orders. Okay, so let's go to this new one I brought. All right, so we are saying we want to bring in subscription type. So I'll come to new column. If you do it this way, let's all can have new column. Subscription type. We said lookup value our customer subscription type, comma, customers, customers ID, comma, our orders column, which is this, bracket close, execute. So you can see that using the lookup value, we are able to also pull our subscription type data from customers table into this orders table without any predefined relationship, unlike that of related. So what you will do, pay attention to the syntax sentence, the way it was written, look at it carefully, and practice and see what you can do, so that you can then connect this with what we have here. I think this answers that problem, because we're told here, how can we link orders to customer details for policy-based segmentation using related and also using the lookup value. So with this, you can then see how all of this can be done. So this is where we are going to draw the curtain to a close. Thanks. Practice using the case study, using the data set. I will see you again next time.